When you're adding or subtracting rational expressions, treat it like any other fraction, addition, or subtraction problem. You have to look for a common denominator first. And as long as the denominator is the same, a common denominator, like here we have 12x and 12x, then you would just add or subtract the numerators like normal. So 5 minus 7 is -2. We keep the denominator because it was common, and then if you can simplify or reduce the fraction, do that. So in this case, my answer would reduce to -1/6x. In the second example, again, they have a common denominator of x plus 1, so we simply add the numerator. 5 plus 3 is 8. We cannot simplify that from there. And in the last example, we have a common denominator again. We add the numerator. Those are not like terms, so it would stay 6x plus 6. In this case, though, we can simplify that numerator by factoring out a GCF. Whenever you can factor, because in factored form, you'll be able to see if anything can cancel out, if it can be simplified further. And we have an x plus 1 in the numerator and the denominator, so our answer would be 6. Now, let's look at some examples where it is not a common denominator. Or actually, first, we're going to talk about how to find a common denominator in general. Or another word for common denominator, it's really the least common multiple. That's what we're finding when we find a common denominator. So if we're talking about how to find a least common multiple, the first thing you're going to do is factor each of the expressions. So 4x squared minus 16, that has a GCF. We factor that out first. X squared minus 4, that's a difference of squares, x plus 2 and x minus 2. And then when I factor out this second set, there's also a GCF there. And we can factor that trinomial into x minus 2 times x minus 2 or x minus 2 squared. So if these were my two denominators and I was going to find a common denominator between them, that's the least common multiple. What you would do is start by looking at your numbers, right? If you had a 4 and a 6 in the denominator, the least common multiple of 4 and 6 is 12. And then because this set has an x plus 2, this expression has an x plus 2 in factored form, we know that we are going to need an x plus 2 factor in our least common multiple. And there's also an x minus 2, so we know that we're going to need an x minus 2 in our least common multiple. Then we're going to go ahead and look at the other expression. The 6 is taken care of with the 12. This x minus 2, we already have an x minus 2 for, but we do not have a second x minus 2. So our least common multiple needs to include 2 of those. So our goal in finding a least common multiple is we need to be able to multiply each expression by something to get this right here. So this first expression, if I multiply 4 by 3, and if I multiply the x plus 2, x minus 2 by another x minus 2, so if I multiply this whole expression by 3 times x minus 2, I would end up with this least common multiple. And likewise, I can multiply the second expression by 2, 6 times 2 is 12, and x plus 2, and I would get this least common multiple. So that's our goal in coming up with a least common multiple or a common denominator here in just a minute, is we need to be able to multiply each original expression by something to end up with your least common multiple. If that was confusing, it might make more sense when we actually start adding these. So in this first example, they do not have common denominators, so our first step is to get a common denominator, also known as a least common multiple. So focus on the denominators. If you can factor. So this second set can be factored. They have a GCF of 3x, and when I factor out a 3x, what's left is x plus 1. Now, I'm going to take a second and think through my least common multiple. So my least common multiple between the 6x squared and the 3x times x plus 1, I'm going to write it up here. I know I'm going to need a 6x squared. My 3x is taken care of by the 6x squared because I could multiply that by 2x. 3x times 2x is 6x squared. And then we also have an x plus 1. So our common denominator is also going to need an x plus 1. So because our first fraction does not have an x plus 1 in the denominator, we're going to need to multiply 6x squared by x plus 1. But you can't just multiply the denominator by x plus 1. Whatever you do, multiply by the denominator, we're also going to multiply by the numerator. Because if I multiply by x plus 1 over x plus 1, that's really just multiplying by 1. So I'm not changing the value of that fraction at all. So now my new denominator for this first set, I'll rewrite the whole thing down here. I have 6x squared times x plus 1 in my denominator. And then my numerator, I have 3 times x plus 1. I'm going to go ahead and distribute the numerator out. Don't distribute the denominator, but go ahead and distribute the numerator. And this would be my new first fraction. Now to do the second fraction. So we already mentioned that we need to multiply by 2x because now I have 6x squared. 3x times 2x is 6x squared. And I have that x plus 1. Remember, this we're ignoring because we rewrote that as 3x times x plus 1. So we have a common denominator now, a 6x squared and an x plus 1 in both denominators. But if I multiply by 2x in the denominator, I also have to multiply by 2x in the numerator. So my new numerator is going to be 2x squared. Now that my denominators match, I have a common denominator, I can go ahead and add my numerators together. So I have 3x plus 3 plus 2x squared over that common denominator. And then I'm going to go ahead and rewrite my numerator in standard form because I need to check to see if it's factorable. If it's factorable, I need to factor my numerator to see if anything cancels out with any factor in my denominator. But 2x squared plus 3x plus 3 is not factorable, so this would be my final answer. Let's do another example. So first step, if your denominators don't match, take a second and factor out a GCF if there's a GCF, or just factor in general your denominators so it's in factored form. And then once it's in factored form, ignore the original denominators. So we have our denominators in factored form. They are not the same. We need to make them the same. So I have x times x minus 3 and x times x plus 2. So if I want them to match, I need an x plus 2 in this one and an x minus 3 in this one, and then the denominators would match. But remember, whatever you multiply by the denominator, you also have to multiply by the numerator. So this time, in this first numerator, I'm taking x plus 5 times x plus 2. So I need to distribute all of that out. So I'm going to get x squared plus 2x plus 5x, which is 7x when you combine like terms, plus 10. And my denominator is x times x minus 3 times x plus 2. And then in my second set, I have 3 times x minus 3. When I distribute that, I get 3x minus 9. And again, my denominator matches. I'll rewrite it in the same order as my first set. But my denominators match now. And because my denominators are common denominators, I can go ahead and add those numerators together. And so to add them, I'm going to combine like terms. So 7x and 3x make 10x. 10 and negative 9 make 1. I'm going to leave the denominator in factored form. And then your last step is to check to see if you can factor the numerator. If the numerator can be factored, factor it to see if anything cancels out with the denominator. But again, in this case, that numerator cannot be factored further, so that's our final answer. Let's try another one. I'll go through this one a little quicker. Start by factoring out, or just factoring. In this case, I needed to factor out a GCF. So if I want these to be common denominators, I'm going to need to multiply this first fraction by another x minus 2. If I do it to the denominator, I need to do it to the numerator. And in the second set, I need to multiply by 3x. So now the denominators match. Both denominators have a 3x and two x minus 2's. So when I distribute in the first numerator, I get 7x minus 14 over that common denominator. I'm going to write it as x minus 2 squared. And then in the second set, I have x squared times 3x is 3x cubed over 3x and x minus 2 squared. Now that the denominators match, I combine like terms. This is not factorable. And so our final answer would be left like this. Here's our first subtraction problem. We pretty much do the exact same thing with subtraction. You just have to be a little bit more careful at the end. When you combine like terms, we need to distribute that subtraction sign. So first things first, we get a common denominator. So if I want the denominators to match, I'm going to need to multiply this denominator by x minus 3. And I'm going to need to multiply this denominator by a 3. So first fraction here, I get x plus 2 times x minus 3. When I distribute that out, I get x squared minus 3x plus 2x minus 6. And then we're going to subtract that when I distribute the 3 in that second numerator. I'll do this in a different color. I get negative 6x minus 3. And our denominators match now. So this time, because we're subtracting, I'm taking x squared minus x minus 6 minus negative 6 minus 3. But I'm subtracting by that whole thing. And so I really need to distribute that negative sign. And this is going to turn into a positive 6x. And this is going to turn into a positive 3 when I go to combine like terms. So I get x squared plus 5x minus 3. That is not factorable again, and so we can stop at this point because our numerator cannot be factored. But if your numerator can be factored, make sure you do that. Another example, we cannot factor a monomial, this second set. I'm factoring out a 3, whoops, I should say 3x squared minus 4. So this one looks a little more confusing because of the 3x squareds, and 3x squareds look like they match, but they don't. 3x squared is different than 3x squared minus 4. So this first fraction does not have a 3x squared minus 4. So we need to multiply by that factor. It's grouped with a subtraction sign, so we cannot separate that 3x squared from that 4. It's all one factor, 3x squared minus 4. Now, it does have a 3, though. We have a 3 here. There's also a 3 there. So that part's good. What we need, though, in our second fraction is we need to multiply by x squared. So when I do that, in my first fraction, I now have 3x squared minus 4 in my numerator, and I have a 3x squared and a 3x squared minus 4 in my denominator. And then when I subtract in my second set, I have x cubed in my numerator. And in my denominator, now I have a 3 and a 3x squared, and a 3x squared minus 4. So our denominators match now. Be careful here. What you don't want to do is you don't want to say, oh, this 3x squared cancels out with that 3x squared. Or sorry, that 3x squared minus 4 cancels out with that 3x squared minus 4. You do not want to do that. The whole point is we want to be able to combine our numerators together. So don't cancel anything out until after your numerators are combined. And now that we have common denominators, we can combine those numerators together. So when I combine those numerators, I have a negative x cubed, a positive 3x squared, and a negative 4. Now we look to see if anything can be factored, to see if anything cancels out. But that numerator cannot be factored, and so this is our final answer. One last example. In this case, I have x minus 4 in the first fraction and x minus 3 times x minus 4 in the second denominator. So my first denominator is missing an x minus 3. In this case, we only have to multiply the first fraction by something. We're going to multiply the first fraction by x minus 3 over x minus 3. And then when we do that, our denominators will match. So in the first fraction, when I distribute, I get x squared minus 3x plus 1x minus 3. And I have an x minus 4 and an x minus 3 in the denominator. And then in my second fraction, we did not have to do anything. Be careful when you subtract. We are distributing that negative sign, so this becomes a negative x and a negative 1 when we combine like terms. So I have x squared minus 3x minus 4 over x minus 4 and x minus 3. This is the first example we've had where we can factor that numerator. The numerator factors into an x minus 4 and an x plus 1. And when we factor that numerator, the x minus 4's cancel. So our answer is just x plus 1 over x minus 3. So some examples for you on how to add and subtract rational expressions.